In this exercise, I'm going to be using Altova's XML Spy to play with XPath in real time against a couple of XML files. And Altova XML Spy is a tool that I covered earlier on in the title. So I'm going to use this tool because it has an XPath evaluator in it that lets you type in XPath expressions and watch the results get evaluated in real time. It's one of the things I like most about this tool is this capability of evaluating XPath expressions against XML files. So let's look inside the exercise folder. If you look in your folder for exercise files, inside the XPath folder, there's a couple of files there. They're the business card and items XML files. So let's open those up. And you can see that they open up in XML Spy. So let's begin with the business card example that we've been using up until now. So I'm going to activate the business card XML file. And then over here in the toolbar, there's a tool button labeled Evaluate XPath. So I'm going to click that, and this brings up the XPath evaluator. So the way this works is I can just type in XPath expressions in here, and it will evaluate the XPath against the document that I've got open in the editor here. So let's take some of the things that we've learned so far about XPath and see how they work. For example, let's just type in the / character. Now recall from the previous lesson that the / character means select the document root. And you can see that when I've entered the / character here, down here in the results window, the document root got selected. I can further refine this by typing business card. And as you see, when I type the name of a tag that is matched, down here in the results window, the XPath evaluator is showing me that tag, and when I click on it, it shows me the selection over here in the source window of the matching tag. So the business card that I typed in here is the root tag right there. Okay, so now we can get a little bit more fancy. Let's type in a further refinement down to the name tag. And you can see now that I have a path going from the root down through the business card to the name tag. And you can see that it resulted in a match. And when I click on it, it highlights the name in the window. The other thing it shows me is the value and attributes of the tag. So inside the name tag, there's the string Joe Marini. That's my name. So, however, I can also further refine the path to select just the text. So if I type another / and then the word text with the 2 parentheses, now it's selecting just the text inside the name tag. So the path leads from the root all the way down to the text inside the name. So that's pretty cool, but we can do some other interesting things as well. Let's back up, and this time we're going to enter a expression that selects the phones. So now you can see that when I type in the phone tag, the resulting node set that comes back is a set of 3 phones. There's the first one, the second one, and the third one. And again, it's showing me the value of the text inside the tag. If I wanted to, I could further refine this selection by entering, for example, inside the predicate expression, which we talked about in the previous lesson, the number 1, which means only select the first phone tag that you come across. And again, I could do 2, and that's the second one, or 3, that's the third one. Or if I didn't know how many there were, I could just use the keyword last. And again, that would select the last phone tag that's underneath the business card. If I didn't care where the phone tags were in the document, and I wanted to just select every phone tag, regardless of whether it was under another tag or not, what I would do is I would get rid of the predicate expression there, and I would put 2 / in front of the phone. And now it's finding all of the phone tags, and you notice that the word business card is gone now. Now it's just finding the phone tags wherever they happen to be in the file. And if there were more phone tags somewhere else in this XML document, not underneath a business card, not underneath any other XML tag, it would just find all of them, regardless of where they are. And again, I can still use the same predicate expressions I was using before. There's the first one, and there's the last one. so everything works just fine. I can also refine the node selection based upon the value of certain attributes or tags. So for example, if I wanted to select the name tag wherever it appears in the file, but I only wanted to select name tags that contain the word Joe, I would write a predicate expression for that, and I would use the contains function, and I would only be interested in name tags whose text contains the string Joe. And you can see that in this case there's one. Now in this case it's the only one, but the point is it's evaluating this predicate against the text content of the element looking for the substring Joe. And you can see that it finds that name tag. I can do the same thing with attributes. So let's take a look at the phone tag. I'm going to replace the name with phone. And in this case, I'm going to say @type. So you can see that when I finish typing the predicate @type, the 3 phone tags show up. And that's because every one of them happens to have a type attribute. And if I wanted to further refine this, I could say @type equals work. Now it only selects the phone tag whose type attribute is equal to the word work. So that's a pretty good tour through this particular document. Let's take a look, however, at the other XML file that we have open. So this XML file is somewhat different. It's a collection of item tags under the root items tag. And we can do a few things here that are interesting as well. So just building on what we've seen so far, suppose I wanted to get all the photos of items that have to do with T. So I would need to build an expression that's going to select the item tag, but only the ones that have T, and then I would need some way to get down to the photo tag from there. So what I would do is I would type a /, and then I would type items. And as you can see, as I'm typing this, the results are coming up down here in the window. So I type another /, and I would type item. So now I will only want to get item tags that have a type that's equal to T, and that results in these 2 items right there. And now I want the photo. So you can see now that I'm selecting the 2 photos that have to do with the T type. So this is a way that you can use predicate expressions that don't happen to finish off the expression. They're used as a refinement at a location step that's above the final step, in this case, photo. So if I just was interested in the item tags themselves, I would just leave off the last photo and get the 2 items here. But by adding the additional step of photo, I've now limited my search for elements that are only of type T, and then I'm getting the photos here. So that's a quick spin through XPath using Altova's XML Spy tool, and we'll be seeing more of XPath later on in the title when we cover XSLT.